Volcanoes, the fiery heart beneath our feet. Every step you take on Earth, there's fire beneath you. Beneath the solid ground we walk on lies a world of molten rock, a restless, seething ocean of heat and pressure. And sometimes, that hidden fury breaks free. This is the story of volcanoes, the fire of the Earth. Welcome to Uncovering Facts, where we explore the mysteries, the science, and the power of our planet. Don't forget to like, share, and subscribe for more incredible documentaries about the natural forces that shape our world. Now, let's journey deep below the surface. Chapter 1: The Fire Beneath Our Feet. Underneath our feet, far below the crust we live on, the Earth burns. The temperature at the center of our planet reaches over 6,000 degrees Celsius, 10,800 degrees Fahrenheit, hotter than the surface of the Sun. This unimaginable heat keeps rocks in a molten state, forming magma, the fiery material that fuels volcanic eruptions. To understand volcanoes, we must first understand the structure of our planet. Earth is made up of four main layers. 1. The crust, the outermost layer, only about 5 to 70 kilometers thick. It's solid rock, everything we see and live on. 2. The mantle, about 2,900 kilometers deep, made of semi-molten rock that moves slowly. Temperatures here can reach up to 3,700 degrees Celsius. 3. The outer core, a liquid layer of molten iron and nickel, generating Earth's magnetic field. 4. The inner core, solid iron, under extreme pressure and heat, reaching about 6,000 degrees Celsius. Volcanoes are the result of these fiery inner forces breaking through the crust, releasing magma, gas, and ash from deep within the mantle. Chapter 2: When the Earth explodes. When pressure builds beneath the crust, magma finds weaknesses, cracks or thin points between tectonic plates, and bursts through the surface. Once magma erupts, it becomes lava, flowing across land, reshaping landscapes, and sometimes burying entire civilizations. One of the most famous eruptions in human history happened nearly 2,000 years ago, in Pompeii, Italy. Chapter 3: Pompeii, the day the sky fell. It was the year 79 AD. Mount Vesuvius, a towering volcano near the Bay of Naples, had been quiet for centuries. But on August 24th, it roared to life with unimaginable power. The sky turned black. Ash and pumice, light volcanic rock, began falling like rain. Within hours, Pompeii and nearby Herculaneum were buried under several meters of ash and debris. People suffocated as pyroclastic flows, fast-moving clouds of gas, ash, and rock, raced down the mountain at hundreds of kilometers per hour. For nearly 1,700 years, the city lay frozen in time until it was rediscovered in 1748. Excavations revealed perfectly preserved streets, homes, and even the shapes of victims' bodies, their final moments captured in volcanic ash. The tragedy of Pompeii reminds us of the awesome, unpredictable power beneath the Earth's surface. Chapter 4: The Monster of Tambora. Fast forward to 1815. Half a world away, on the island of Sumbawa, Indonesia, a volcano named Mount Tambora erupted, the largest in recorded history. The explosion was so massive it created a huge caldera, a crater over 6 kilometers wide and 1,000 meters deep. It blasted more than 150 cubic kilometers of ash and rock into the sky, darkening the atmosphere across the globe. The effects were catastrophic. The eruption killed over 71,000 people, and ash clouds blocked sunlight for months. The following year, 1816, became known as the year without a summer. Crops failed, temperatures dropped, and famine spread across Europe and North America, all because of one eruption on the other side of the world. Chapter 5: Other eruptions that shaped history. Throughout history, volcanoes have repeatedly reshaped the planet and humanity. In 1902, Mount Pelée on the Caribbean island of Martinique destroyed the city of Saint-Pierre, killing nearly 30,000 people within minutes as pyroclastic flows burned everything in their path. In 1980, Mount St. Helens in the United States erupted violently, blasting away the top of the mountain and flattening 600 square kilometers of forest. And in 2024, the world once again witnessed the raw power of nature when a volcano erupted in Iceland. Rivers of lava surged through the Reykjanes Peninsula, forcing evacuations and lighting up the night sky. Scientists believe it was part of a new volcanic cycle that may continue for decades. Every eruption, from ancient times to today, is a reminder that the earth beneath us is alive, constantly reshaping itself. Chapter 6: The source of the fire, magma and tectonic plates. So where does all this fiery material come from? Deep within the mantle, rocks are under such pressure and heat that they melt into magma. This molten rock rises through cracks in the crust because it's less dense than the solid rock above it. But volcanoes don't appear randomly. They form mostly along the edges of tectonic plates, the massive slabs of Earth's crust that fit together like a jigsaw puzzle. When these plates collide, pull apart, or slide past one another, they create the conditions for eruptions. There are three main ways this happens. 1. Subduction zones, where one plate dives beneath another, melting rock and forming volcanoes like those in Japan and Chile. 2. Rift zones, where plates move apart, like in Iceland or along Africa's Great Rift Valley. 3. Hotspots, where plumes of magma rise from deep within the mantle, such as in Hawaii. Chapter 7: The Ring of Fire. Most of the world's volcanoes are not random, they lie along a horseshoe-shaped zone called the Ring of Fire. Stretching over 40,000 kilometers, this ring encircles the Pacific Ocean, marking the edges of major tectonic plates. It includes Volcano Japan, Volcano Indonesia, Volcano the Philippines, Volcano Papua New Guinea, Volcano New Zealand, Volcano the west coasts of North and South America, from Chile to Alaska. Around 75% of all active volcanoes on Earth are found along this fiery belt. The Ring of Fire is both destructive and creative, destroying landscapes while building new ones through eruptions and island formation. Chapter 8: The Dangers of Volcanoes. Volcanoes are magnificent, but deadly. Their eruptions can unleash forces beyond comprehension. Here are some of the most dangerous effects. 1. Pyroclastic flows, superheated clouds of gas, ash, and rock moving up to 700 km per hour. 2. Lava flows, rivers of molten rock that destroy everything in their path. 3. Tephra, volcanic ash and debris that can collapse roofs, poison crops, and block sunlight. 4. Toxic gases, sulfur dioxide, carbon dioxide, and chlorine that suffocate or cause acid rain. 5. Lahars, volcanic mudflows formed when ash mixes with rain, burying towns like wet cement. Volcanic eruptions have changed climates, wiped out civilizations, and even altered history. Chapter 9: The Benefits Hidden in the Fire. But volcanoes are not only destructive, they also bring life. Volcanic regions are some of the most fertile on Earth. Ash adds nutrients to soil, creating farmlands that can feed millions. They also give rise to precious resources. Gold, silver, and copper deposits form in volcanic zones. Geothermal energy, clean and renewable, harnesses heat from magma deep underground. Hot springs and geysers, like those in Iceland and Yellowstone, attract millions of visitors. Volcanic gases contribute to the formation of Earth's atmosphere. Eruptions can even create new islands, like Surtsey, born off the coast of Iceland in 1963. And globally, eruptions can cause volcanic winter, temporary cooling of the planet, sometimes balancing rising temperatures by dimming sunlight. Even in destruction, volcanoes shape and sustain life. Chapter 10: Predicting the Unpredictable. Can volcanoes be predicted? Not perfectly, but science is improving. Volcanologists use several warning signs to forecast eruptions. 1. Seismic activity. Small tremors often occur before an eruption. 2. Gas emissions. Rising levels of sulfur dioxide indicate magma is near the surface. 3. Ground deformation. Swelling or bulging of the volcano's surface shows pressure building up. 4. Temperature and thermal imaging. Hot spots suggest magma movement. By combining satellite data, sensors, and field studies, scientists can often give days, or even weeks, of warning before a major eruption. However, predicting the exact time and magnitude remains one of Earth science's greatest challenges. Chapter 11. Types of volcanoes. Not all volcanoes are the same. They come in different shapes and sizes, each with unique behavior. 1. Shield volcanoes. Wide, gently sloping mountains formed by fluid lava flows. Examples: Mauna Loa and Kilauea in Hawaii. 2. Stratovolcanoes. Composite volcanoes. Tall, steep-sided, explosive giants like Mount Fuji in Japan and Mount Vesuvius in Italy. 3. Cinder cone volcanoes. Smaller, built from ash and rock fragments, often short-lived. Example: Paricutin in Mexico. 4. Calderas. Enormous depressions formed when a volcano collapses after a massive eruption, like Tambora and Yellowstone. Each type reflects the balance of pressure, gas, and magma beneath the crust, a delicate system that determines whether an eruption will be gentle or catastrophic. Chapter 12. A living planet. Volcanoes are reminders that Earth is alive, dynamic, restless, and ever-changing. They created the first continents, formed our atmosphere, and shaped the land we live on. Without them, there would be no fertile soil, no geothermal power, no new land rising from the sea. But with them comes danger, fire, ash, and destruction. A reminder that the same planet that gives us life can also take it away in moments. From Pompeii's ashes to Iceland's glowing lava, volcanoes tell a story older than humanity itself, a story written in fire and stone. Don't forget to like, share, and subscribe to Uncovering Facts for more incredible explorations of the planet we call home. And in the comments below, tell us, which volcano fascinates you the most?